Hey guys, today we are going to start our trig class by reviewing how to simplify some radical expressions. So the first thing we're going to review is that if you have two radicals being multiplied together, you can just multiply the insides. So the square root of 5 times the square root of 7, you can rewrite that as the square root of 5 times 7, or just the square root of 35. Now, once you get down to square roots like this, you need to check and see if they break down into any perfect squares that you could then possibly take out of the square root. 35 is just 5 times 7, and neither of those are perfect squares, so this would be our final answer here. But if we look at the next problem, 48, we could split 48 into 16 and 3, or we could also split 48 by dividing it by 4. If we divided it by 4, we would get 4 and 12, and then we could keep breaking down that 12. There's a couple different possibilities here. I'm going to use the 16 and 3 because then I am already down to 3 being a prime number, and I just have to worry about the 16. So I'm going to split it as a square root of 16 times 3, and I can kind of split it apart, kind of the opposite of what I just did in the last one. So the square root of 16 times the square root of 3, separating them into two different square roots. Then I know the square root of 16 is just 4. So I can write that as 4 times the square root of 3, and that would be my simplified answer. So our goal here is to try and take out as many perfect squares as we possibly can. Now, my next example, I've got a fraction here, and what we need to remember for this class is that we can never, ever, ever have radicals dealing with our denominators. So if I'm looking at the square root of 5 over 64, I cannot leave it like this. I cannot have a radical dealing with a denominator, which would be our 64 in this case. What I can do here is I can split it, so it's the square root of 5 over the square root of 64. So I can split it into two separate square roots, the top and the bottom. And then lucky for us, the bottom is a nice, pretty perfect square. So we're going to simplify this down to the square root of 5 over 8. And that's all we have to do here. But on the next one, it's not nice as nice and pretty as this last one was. Our denominator is the square root of 2, which is not a nice perfect square. So there's not really as much that we can do here. On the top, I have the square root of 8. And I can simplify that. I can split that apart. 8 can be 4 times 2. So I can write that as the square root of 4 times 2 over the square root of 2. My pen is really lagging right now. So I could split that as the square root of 4 times the square root of 2 over the square root of 2. And you will notice that these are going to cancel out. So I just get down to the square root of 4, which is just 2. So same idea, we want to see if there's anything that we can take out and see if that'll help us simplify and cancel out. If it doesn't, then we will use a process called rationalizing the denominator, which we will look at on the back of these notes. So now that we've kind of covered some basics here, I've got two examples here that have some pretty common mistakes that I've seen my students make. So if we're looking at the first one, we started with the square root of 60. So finding the mistake in this problem, if you want to pause the video and see if you can find the mistake and fix the mistake, I'll give you a second to do that. Okay, so what they did is they split 60 into 4 times 15. Then that would be the square root of 4 times the square root of 15. But if you look right here, the square root of 4 is not 4. The square root of 4 is 2, so it should be 2 square root of 15. Make sure that when you take the square root there, you actually do take the square root there. Square root of 4 is 2. Make sure you actually take the square root. Now try the next one. See if you can find the mistake and correct it. I'll give you a minute to pause the video and see if you can do that. Okay, so for this one, they split 91 into 13 and 7, 13 times 7. So the square root of 13 times the square root of 7. And you'll see right here, 13 and 7, neither one of those is a perfect square, but they still tried to take the square root of 13, and you cannot do that. If you get down to something that looks like this, where neither one of them is a perfect square, then that actually means that the square root cannot be simplified. You would just leave it exactly how it was where you started. Don't assume that just because it's a square root, it can be simplified. Sometimes they can't. Sometimes you just leave them exactly how they started. So make sure that you're being aware of those common mistakes and making sure that you don't make those mistakes. Okay, the next things that we're going to look at, we are going to add and subtract a little bit. Then we're going to multiply, and then we're going to do some rationalizing the denominator and dividing. So if we're adding or subtracting radicals, we need to make sure that they have the same number inside of the root. And they have the same index, which means they are both square roots, or they're both cubed roots, or they're both fourth roots. So right here, we do have that they are both square roots, but the first one is 2 square root of 12, and the second one is 3 square root of 75. So we're not taking the square root of the same thing. So we need to break these down and see if we can get it to where we are taking the square root of the same thing. So I'm going to start with my 12, and I'm going to break that down. So I'm going to think about all the things that multiply to 12. I could do 2 and 6, but neither of those are perfect squares, so that's not really going to help me. So I'm going to go with 3 and 4 because 4 is a perfect square. So make sure you're being strategic about what numbers you use. That would be 2 square root 4 and square root 3. So 2 times the square root of 4 times the square root of 3, which I know the square root of 4 is 2, so 2 times 2 times the square root of 3. And that 2 times 2 is going to give me 4 square root 3. Then I'm going to look at my next one. So over here, I can see that I've got 75. So I need to think about some things that multiply to 75. And the first thing that comes to mind for me is quarters, thinking about money. That's going to be three quarters. So 25 times 3. And 25 is a nice, pretty perfect square. So 3 times the square root of 25 times the square root of 3. And the square root of 25 is 5. So 3 times 5 times the square root of 3. And 3 times 5 is 15. So I get down to the 15 times the square root of 3. Now if you look, we do have the same thing inside of our roots. They're both square roots, so now I can just add them together. And so I'm looking at my first term being like I have 4 square roots of 3. The second term is I have 15 square roots of 3. So I'm taking 4 and I'm adding 15 of them to it. So my final answer here is that I'm going to be 19 square roots of 3. Think about that square root of 3 as the item that you're adding together. So that's the part that doesn't change. The coefficient, the number in front, is the part that changes. So 19 square root of 3 is our answer. Let's look at the next one. I'm going to try and break down that 18. So I am going to look at that and I'm going to think of all things that multiply to 18. So 3 and 6, not really super helpful, but 9 and 2 is because 9 is a perfect square. So the square root of 9 times the square root of 2 is going to give me 3 square root of 2. I'm going to start skipping some of the steps here because I think we're getting the idea. Now I'm going to look at that 27, and same thing, 9 goes into 27. So square root of 9, but this time times 3. The square root of 9 times square root of 3. So 3 square root of 3. But you'll notice in my first square root I have a 2, but in the second square root I have a 3. So since they do not have the same thing inside of the square roots, I cannot combine them. So I'm going to leave it as 3 square root of 2 minus 3 square root of 3. There's nothing I can do to combine these two. That's it. Now let's talk about some multiplying on the back of our notes. When I am multiplying, we're going to use very, very similar properties to what we do with our numbers that don't have square roots. So if I have something in front of a parentheses like this, I'm going to distribute just like I would when I didn't have square roots. The square root of 6 times the square root of 5 would be the square root of 6 times 5. And 6 times 5 is 30, so the square root of 30. The square root of 6 times the square root of 7 means I'm going to have a minus that, so minus square root of 6 times 7, so minus the square root of 42. I'm going to wait for my pen to catch up. Here we go. And then once we get to this, we would need to see if we can break down these square roots at all. So if I'm thinking about 30, I'm going to think about all the things that multiply to give me 30. I already know 6 and 5, but those aren't perfect squares, so that's not going to help me. 3 and 10, those aren't perfect squares either. 2 and 15, not perfect squares either, so it's not really going to help me. So when I think about all the different things, there's nothing in 30 that's a perfect square that I can take out, so I can't break down that square root of 30. I'm going to do the same thing for the square root of 42, and I'm going to come to the same conclusion. I cannot break that one down either, so this is my answer here, the square root of 30 minus the square root of 42. So don't forget to check and see if you can break them down. Sometimes you can, sometimes you can't, so make sure you are checking. What's a little bit different about this one over here is my first part of my parentheses is just a 2. There is no square root. So when I distribute that square root of 5 times 2, make sure that you're writing it as 2 square root of 5. The 2 is not in the square root, so you cannot multiply those numbers together. It stays as a coefficient. So 2 square root of 5. And then when I come over here, I've got the square root of 5 times the square root of 6. So that's where I can multiply the insides together. So I get 2 square root of 5 plus the square root of 5 times 6 is 30. And we already know from the first part that that square root of 30 is not going to break down. So that's my answer. And just like we would distribute when we have something in front of the parentheses, when we have two parentheses, we're going to FOIL or double distribute or box method, whatever you were taught back in algebra. So I was taught FOIL, so that's what I'm going to use here. So I'm going to do first times first, which means I'm going to have the square root of 10 times the square root of 10. The square root of 10 times 10, which would be the square root of 100. Then I'm going to have outside times outside, so minus the square root of 10 times the square root of 3. So the square root of 10 times 3, so minus the square root of 30. Inside times inside, square root of 3 times the square root of 10, so plus that square root of 3 times 10, so plus the square root of 30. And last times last, minus the square root of 3 times the square root of 3. So the square root of 3 times 3, minus the square root of 9. Now I know that there's some stuff that you probably could have simplified in your head here. Totally get that. I'm just writing out all the steps to make sure that we can see everything that's happening here. And what you may notice is that our two middle terms, I have a minus the square root of 30 and plus the square root of 30 that are going to cancel out. Then the square root of 100 is 10. Then over here I have a minus the square root of 9 is just 3. So I'm looking at 10 minus 3, which gives me my answer of 7. So when I multiply all of this together, I get down to a nice, pretty whole number answer. Now, that doesn't always happen, but this one it did. So nice and easy. Let's look at the next one. I do have the square root of 7 minus 3 squared. Do be careful with this. You cannot distribute the squared because you have that subtraction there. So this is another one where we're going to have to FOIL. I'm going to write it out twice and FOIL it out. So first times first, square root of 7 times the square root of 7 would be the square root of 7 times 7, which is 49. When I do outside times outside, Be careful. Remember, one's in a square root, one's not. So that's going to be minus 3 square root 7. I can't multiply those numbers together. Inside times inside, same thing. Minus 3 square root 7. And last times last, negative 3 and negative 3 is going to give me plus 9. Be careful with your signs here as well. So when I'm looking at this one, the square root of 49 is 7. These middle two terms I can combine, so I get minus 6 square root of 7, and then I still have that plus 9 on the end. And if I have 7 plus 9, I can also combine those two terms. 7 plus 9 is going to give me 16, so my answer would be 16 minus 6 square root of 7. Make sure you're being really, really careful with your signs. That's where I see a lot of people make mistakes. And then the last part that I was talking about, when we have our square roots in our denominators, remember we cannot have square roots in our denominators, so we're going to use the process called rationalizing the denominator. So if you notice, all of these have multiple square roots in the denominator, or something plus a square root, something minus a square root, something like that. So in order to simplify this, we are going to have to multiply by something called the conjugate. Now, if you remember from our college algebra class that we took last semester, we did talk about conjugates when we talked about complex numbers. When we're talking about conjugates, complex numbers come in conjugate pairs. It's A plus BI and A minus BI. Here, we still have conjugates, but instead of the I part, it's just the A plus B or A minus B term. My pen is really not working with me today. So if I'm looking at the first one over here, I've got the square root of 7 minus the square root of 2 in the denominator. So I'm going to multiply by the conjugate of the denominator. So I'm going to multiply by the square root of 7 plus the square root of 2. And I'm going to multiply the top and bottom by that. It's a fancy way of saying I'm multiplying by 1. The square root of 7 plus the square root of 2 over the square root of 7 plus the square root of 2 would simplify down to 1. So I'm just multiplying by a really fancy 1. And if you look at our example right above in green, we actually multiplied by conjugates right there. Square root of 10 plus square root of 3 and square root of 10 minus square root of 3. And you'll notice when we multiplied by conjugates, that's when we get down to that nice pretty whole number answer. And so that's kind of the goal here, is we want to get a nice pretty whole number in our denominator and get rid of those square roots in our denominator. So that's why we want to multiply by the conjugate, because it'll get us down to a nice pretty whole number in our denominator. So if I'm looking at the numerator, the top of the fraction, I'm just going to distribute the 6 to my parentheses. So that's going to give me 6 square root of 7 plus 6 square root 2. On the bottom, I have a parentheses times a parentheses, so I'm going to have to FOIL this out. So first times first, square root of 7 times square root of 7 is going to give me square root of 7 times 7, or 49. Outside times outside, square root of 7 times square root of 2, so the square root of 7 times 2, or 14. Inside times inside is a negative square root of 2 times square root of 7, so minus square root 2 times 7 is 14. And last times last, another minus, so negative square root of 2 times square root of 2, the square root of 4. So those middle two terms are going to cancel out nice and pretty for us again, like they did in the example above. My numerator is still that 6 square root of 7 plus 6 square root 2. In the bottom, though, now I have two pretty perfect squares that I can simplify. The square root of 49 is 7, minus the square root of 4 is 2. So in the bottom, I have 7 minus 2, which will simplify down. 7 minus 2 is 5. So 6 squared is 7, plus 6 squared is 2 over 5. And that would be my answer. No more square roots in the denominator, because we cannot have square roots in our denominators ever. Let's look at the next one. This time, my conjugate that I'm going to multiply, my denominator is 1 plus the square root of 2. So my conjugate that I'm going to multiply by is 1 minus the square root of 2. We flip that sign. So same idea. In the numerator, I'm just going to distribute. The 3 times 1 is 3. 3 times that negative square root of 2 is going to give me minus 3 square root of 2. And in the bottom, I need to FOIL it out. So first times first is 1. Outside times outside, minus square root 2. Inside times inside, plus square root 2. And last times last is going to be minus square root 2 times 2, which is 4. Our two middle terms are going to cancel out. So on the top, I still have 3 minus 3 square root 2. On the bottom, that first term is still 1, but over here, this minus square root of 4 is going to change to minus 2. And 1 minus 2 is just negative 1. So 3 minus 3 square root of 2 over negative 1. But what's a little bit different here compared to our last one is that I can divide those by negative 1. So I do need to divide those by negative 1. So 3 divided by negative 1 minus 3 square root of 2 divided by negative 1. 3 over negative 1 is going to give me negative 3. And then over here, those negatives are going to cancel out. So I get plus 3 square root 2. So if you can divide and simplify, you need to divide and simplify. Now, what's a little bit different about our last example over here is the top is not just a single number. We've got some square roots at the top. When we are rationalizing the denominator, you need to make sure that you multiply by the conjugate of the denominator every single time. So multiply by the conjugate of the bottom. So my denominator, the bottom of my fraction, is the square root of 5 plus the square root of 3. So what I'm going to multiply top and bottom by is the square root of 5 minus the square root of 3. So let's multiply it out. On the top, first times first, square root of 2 times square root of 5 is going to give me the square root of 10. Outside times outside, minus the square root of 6. Inside times inside, minus the square root of 15. And last times last, a negative square root of 3 times a negative square root of 3 gives me plus the square root of 9. On the bottom, first times first, square root of 25. Outside times outside, minus the square root of 15. Inside times inside, plus the square root of 15. And last times last, minus the square root of 9. So on the bottom, that minus square root of 15 and plus square root of 15 are going to cancel out. On the top, there's not really much that we can do other than simplify that square root of 9. It's going to be the square root of 10 minus the square root of 6 minus the square root of 15 plus, and the square root of 9 is just 3. On the bottom, I have a square root of 25, which is 5, and then I've got minus the square root of 9, so minus 3. And 5 minus 3 is 2. So the numerator is kind of long and not super pretty looking, but on the bottom, we do get down to a nice pretty whole number with no more radicals, no more square roots. Okay, so we will be working with radicals and square roots a lot this semester. You need to make sure that you remember how to simplify them. Make sure you remember how to work with them. That's it for today's notes. Make sure you get started on your assignment that goes with this. Let me know if you have any questions, and y'all have a good day.